SpaceX is nothing if not audacious. The 2018 awe-inspiring launch made Falcon Heavy the world's most powerful operational rocket, and at the same time it made SpaceX the pride of America, causing Russia, China, and Europe to grow envious. And after a 3-year hiatus, this monster still proves itself to be an engineering masterpiece, shocking NASA scientists with its latest launch. But when all is said and done, how powerful is it? The Falcon Heavy, according to SpaceX's website, is 70 meters tall and can lift nearly 64 metric tons of payload to low Earth orbit, about twice the payload capacity of its closest competitor, United Launch Alliance's Delta IV Heavy. The rocket has 2 stages. The first stage has 3 engine cores. The center core is flanked and supported by 2 boosters. Each core is equivalent to the first stage of a Falcon 9 rocket and houses 9 Merlin engines. The boosters separate after liftoff and land upright back on Earth, possibly to be used again. Meanwhile, the heavier center core aims for a drone ship carrying its payload in the second stage. The 27 engines on the first stage of Falcon Heavy working together are capable of more than 5 million pounds of pound force of thrust at liftoff, which is equivalent to 22,819 kilonewtons. The same force as about 18,747 aircraft at full power. No, you heard that right, I'm talking about the Boeing 747 jumbo jets that you would see at airports, but not 1, not 2, not 3, not 4, not 5, unless it's not even up to 10, it's 18 of those. That's basically a whole airport, which is crazy in any case. The Falcon Heavy lifted off for the first time on February 6 of 2018. From Kennedy Space Center in Cape Canaveral, Florida, using Launch Complex 39 of that once hosted moon-bound Apollo astronauts and space shuttle crews. The rocket launched a red Tesla Roadster and a space-suited mannequin called Starman in an orbit around the Sun that could extend past Mars. An estimated 100,000 spectators crowded the area's benches and beaches and roadways to watch the rocket launch. Millions more watched the live stream showing the launch and events afterward. As a quick note, that Roadster is still alive. A literal car is cruising out there in our solar system, and as the kids say, we are truly in the right timeline, and it'd be greater if one day NASA's $10 billion machine, the James Webb Telescope, could capture a few moments of the first and only flying car in our solar system. It does seem like a stretch, but you never know, could happen. Not this year. Maybe not next year, but sometime in the future we might get that sweet money shot of that Tesla Roadster and Starman waving back at us through the lens of the James Webb. The historic Falcon Heavy launch made it the world's most powerful rocket in operation and the 3rd highest capacity launch vehicle ever to reach orbit, following NASA's Saturn V rocket and Russia's Inertia rocket, which are no longer operational. The 3 core rockets' reliability to launch a heavy payload to space. That's why nowhere did this launch echo as powerfully as in Russia. The private U.S. company once again created a technical feat on which the Russian space industry has given up on: the successful launch of a rocket with as many as 27 engines. When SpaceX's Falcon Heavy debuted, China's aerospace community was mostly envious as their equivalent rocket. The Long March 9 rocket, speculated to be a copy of SpaceX's Falcon Heavy, would not be ready for another decade. All in all, the video of 2 boosters landing side by side left a powerful impression on the minds of the general public on the value of rocket reuse. Sadly, after 2 flights in 2019, this rocket was completely absent. But it wasn't until 2022 that the monster officially returned to the track with the USS F-44 mission. The Falcon Heavy took off probably at 9:41 a.m. Eastern Time on November 1, climbing steadily above the Florida coast on its way to orbit. A few minutes into the launch, 2 side-mounted boosters, which are slightly modified versions of SpaceX's Falcon 9 rocket, peeled away from the center core of the rocket. As that center core continued to climb toward orbit, the boosters fell back to Earth, burning a subset of their 9 engines twice and making a picture-perfect side-by-side landing. Meanwhile, the SLS, with its countless delays and budgetary issues, has become NASA's most controversial project in recent years, perceived as an outdated, unnecessary money sinkhole and a symbol of everything wrong with the industry. Despite spending a decade and over $1 billion preparing the SLS and mobile launch tower for the Artemis 1 mission, NASA is still brittled with seemingly unending problems. The SLS still remains unoperational, and the mobile launcher developed along with it is a black hole and a failure, sucking Millions in modifications and development costs, but what is causing the delays and unending complications, and is NASA doing anything about it? ML1. The Leaning Tower of NASA. After spending nearly $1 billion constructing and modifying the ML1, it was finally ready, only for NASA to come out with troubling news. The tower was leaning. The mobile launch structure was built to propel the enormous next-generation rocket SLS into space. It was designed to support testing and servicing of the Space Launch System and provide access to communications, power, fuel and coolant to the 355-foot-tall rocket, although NASA released a statement saying that the lean was not too serious to result in any redesign or modifications. Additional parts were going to be installed in the leaning structure. They explained that the leaning nature of the launch tower was likely due to a combination of welding the different levels and modifying them one at a time, and that it was to be expected of such a large structure. Other natural factors like wind, temperature and vibration were held responsible for the change in structure to stop the tower from leading more. When new installations are added, the engineers will remove all the lightweight fiberglass grating on the tower and replace it with heavier steel grating. However, this change will not only bring in more problems, as it will add an additional 750,000 pounds, taking it 1 million pounds over the desired weight. This isn't great for something that has to be moved around with a heavy rocket on it. Despite the extensive time and cost of the project, it will be replaced after 3 missions because NASA needs another launch tower for a different version of the SLS with a more powerful upper stage that would extend the rocket's height by 40 feet for later trips to the moon. But how did a simple modification estimated to cost $54 million skyrocket to $914 million and a leaning tower that can only be used 3 times? NASA's finalization of the SLS and Orion requirements came in late and caused key components of the ML1, likely on umbilicals, to be modified. The agency also had no comprehensive process to coordinate work from different contractors into one cohesive design, taking the spotlight away from themselves. NASA placed a lot of blame on the cost-plus contract signed with a company called Vencor, which provided designs for ground support equipment. But NASA is not completely blameless. The agency accepted unproved and untested designs from Vencor just to advance the construction and fabrication of contracts, and were fully aware that the subsystem designs were not complete and needed more testing. When it resulted in significant delays and costly rework, they refused to punish or criticize Vencor for their poor performance. The employees at the Kennedy Space Center gave the company excellent or very good ratings, saying that Vencor performed well due to the obstacles that had to be overcome despite the fact that the structure was behind schedule and well over budget. This mistake on NASA's part added fuel to the already burning criticism that the SLS project was only created to maximize jobs rather than furthering U.S. presence in space. Now NASA is working on the second mobile launcher to accommodate the larger Block 1B SLS rocket. The estimated budget for the project was set at $383 million and was set to be delivered by 2023, but it has already started running into problems. The ML2 construction. Even though NASA hasn't launched or tested the capabilities of the existing SLS rocket, they insisted on building a larger and much more capable rocket that required another mobile launcher to be manufactured. The new contract was awarded to Bestow National in 2020. Until this moment, design work of the ML2 hasn't begun. According to George Neil, Bechtel is experiencing some challenges and performance issues because they had underestimated the complexity of the project. How does that even happen? The pandemic also put a major pause on the company's plans. NASA has already written to Bechtel asking for an assessment of the project's risks and to basically speed up the projects that can be used as soon as possible, but that doesn't fully excuse the delays the ML2 project has experienced. Writing a scathing report, NASA's Inspector General revealed that the project is already running years behind schedule before it even leaves the ground. The launcher weighs too much and it is millions of dollars over budget, with a new cost of $960 million that is enough for over 20 Falcon missions. Earlier this year, NASA had given an additional $435.6 million to the project, and Mitchell does not expect construction to begin until the end of the year or next year at the earliest convenience. Despite the support and lack of admonition in the past towards Bechtel, NASA's administrator Bill Nelson bashed the company for bidding on the contract. The project they cannot just back out. In Nelson's own words, NASA is stuck, but once again NASA doesn't exactly have clean hands. The space agency awarded the contract at Bechtel before specifications for the SLS upper stage, called the Exploration upper stage, were finalized, and the lack of specifications to accommodate the EU's paused the design of the second launch tower. NASA is currently taking steps to re-evaluate the project's budget, schedule estimates and the contract with Bechtel, but the tower will probably be not ready for use till 2026 or 2028. Given NASA's long history with unexpected issues affecting launches, the agency has also done something unprecedented by taking some work off Bechtel's plate but still making all the payments, while Bechtel will focus on the core project. The development of the umbilicals will be given to another contractor and given to Bechtel for integration with the tower by that time. The cost of the ML2 is expected to be $1.5 billion, more than 2 times the original budget. Why Artemis delays? NASA won't be needing the ML2 anytime soon, as it intends to complete the first 3 missions of the Artemis program using the first mobile launcher the agency plans to launch the first mission between the 16th of November and 9th of December this year, but there's no telling if that would happen. After all, the SLS launch is already 5 years behind its original schedule and every attempt to launch the rocket this year has been met with complications. The first flight of the SLS was supposed to happen in April, was scrapped due to fuel leaks, and the teams immediately came on board to address the next launch attempt. Scraped again, the engineers had to fix a hydrogen fuel leak in one of the rocket's engines, and when it wasn't possible, the launch was pushed October and eventually November. The agency did say they were going to take slow steps with the Artemis program because they wanted to get it right, and the question now is, how slow are they going to go? The SLS has been in development for decades already and has cost $23 billion to build, so since they are building another version of the SLS that is intended to be better than the current one, the only way they can be sure of its capabilities in the work ahead is to test the one they have already got. If the rocket is not launched by mid-December, NASA will have to examine 2 of the rocket's boosters that are expiring within that time frame. The boosters developed by Northrop Grumman had a 2-year deadline, with the first expiring on the 9th of December and the other on the 14th of December, and the expirations for the rocket boosters cannot be extended. NASA will have to replace the booster without ever fully using them and push back the launch by months or years until new boosters are available. The clock is ticking for the Artemis 1 launch, and ticking fast. NASA has to move fast if they want to successfully launch this year and justify the times and billions spent on the project. They will also have to meet the expectations of millions. We'll see you next time. Thank you very much for watching. BHA. Bye.